Hello everyone. In this video, I want to continue where I left off in a previous video where we were working in a folder called list fun. We derived this main.py file which provided an introduction to working with lists in Python. Our next topic is list aliasing. This is a super important concept in Python that ties into a bigger picture, which is Python is passed by object reference. So we'll use this as a nice segue to that conversation. For this demo, let's declare a few lists. Let's say I have list 1, which stores 1, 2, and 3. Let's say I have list 2, which stores 1, 2, and 3. So it looks like list 1 and list 2 refer to the same list, but they actually refer to two different list objects in memory. So I'm going to print these out. As we're going through this list aliasing and soon this Python is passed by object reference section of our notes, I'm going to switch over to my iPad and draw what these references and these list objects look like. So I've just declared a variable called list1. It refers to this list in memory. I've also declared a second variable, list2, which refers to this list in memory. Note that even though they have the same values in the list, these are two different list objects. This is going to be really important for what we're about to do. Go back to the code, and let's say I'm going to overwrite list 1's first value with 100. And then I'm going to print out both lists again. Take a moment and predict what the output is going to be from line 103. Remember, list 1 and list 2, even though they have the same elements in their list, refer to different list objects in memory. So I run this and I see that the 1 in list 1's object has been replaced with 100 and the 1 in list 2's object has been unaffected. So if I pull this back to our memory diagram here, I'm going to overwrite the 1 with 100. Back to the code. Let's up the complexity just a little bit here. Let's say I declare another variable, I'll call it list3, and I'm going to assign to list3 list1. Now, there are two possible outcomes for what could happen right here. One is list3 could become a copy of list1, meaning an entire new list object is created and all of the values in list1 are copied into that new list object. That is not what happens here. The second option is what does happen, which is list3 becomes an alias for the same list object that list1 refers to. I'll update our memory diagram here in a moment. Now let's say I print out list1, list2, and list3. Make a prediction about what we're going to see from the output on line 105. So I'm going to run this. And I see list 1's object, I see list 2's object, and then I see list 1's object again. That's because I can now use list 3 to refer to the same object that list 1 refers to. So let's update our diagram here. There's now this new variable, list3, and it stores a reference to the same list object that list 1 stores a reference to. That's why we say list 3 is now an alias for list 1. Now let's say I use list 3 to modify a list. Let's say I want list 3 sub 1 to be assigned 200. I'm going to print out these values again. Make a prediction about what you think is going to be printed. I'll run this. And you can see that the 2 in the object that both list 1 and list 3 refer to has been replaced with 200. So I'll update the memory diagram to reflect what just happened. List 3 refers to this object on the left. Element 1, remember zero-based indexing, is overwritten from 2 to 200. So if I print out the object, the list object that list 1 refers to, I'm going to see 100, 203. If I print out the object that list 2 refers to, I'm going to see 1, 2, 3 because the object that list 2 refers to has been unaffected by any of our changes, separate object in memory. And then if I print out list 3, I'm going to see 100, 203 because remember list 3 is an alias for the same object that list 1 refers to. So like I said, list aliasing is kind of a segue to a much larger, bigger picture topic, which is Python is pass by object reference. If you're coming from another programming language, you might have heard of pass by value, you might have heard of pass by reference. Pass by object reference is a little bit of both. I'm going to walk you through it. We'll do some demos, we'll draw some pictures, and hopefully by the end of this, you're feeling pretty good about what is pass by object reference. In simple terms, Python is passed by object reference means that object references are passed by value, meaning they're copied. So you're like, okay, those terms seem simple, but when strung together, what do they mean? Let's do a demo. Let's say I have a variable, I'll call it matrix, and let's say matrix stores 1, 2, 3, 4, 5, 6. So it's going to be a nested list, which is just a list where the elements themselves are also lists. This is two-dimensional. I'll print out matrix so you can see it. Let's say I write a function called add1 that accepts a two-dimensional list. I'll call this generally table, just so that I have a different variable name than matrix, even though I could use the same one, but using a different variable name will make it really clear what's going on when we draw our diagram here. So the purpose of this function add1 is it's going to walk through each element in table, and it's going to add 1 to that element. So I've got a two-dimensional list, so I need a nested for loop. I will refer to my rows, J will refer to my values within a row. So I'll do table sub I sub j plus assign 1. I'm going to clearly label my output here. I'll do matrix before I call add1. I'll call add1, passing in matrix, and then I'll print out matrix after. So take a moment and make a prediction about what line 120 is going to print. So I run this and I see matrix before stores the same values I initialized it to. Two lists, each list has 3 elements, 1, 2, 3, 4, 5, 6. And then add1 goes through and adds 1 to each element. And it seems like that add1 modification persisted to the object that matrix refers to in the calling code, meaning outside of the scope of the table parameter variable. So let's draw a picture to see what's going on here. Put some squiggly lines here to denote that we're working on a new demo. So I have matrix. Matrix refers to this list. Now I call add1, passing in matrix. There's a parameter in add1 called table. What happens is the object reference that matrix stores is copied into the table parameter, effectively making table an alias for the same object that matrix refers to. Therefore, Any modification we do to a list via table is a modification to the same list that matrix in the calling code refers to. That's why the change, add 1 to each element, persisted to our calling code. Matrix was changed by table the parameter inside of our add 1 function. So let's write this down to explain what's going on. The matrix object reference is copied into the table parameter, thus making table an alias for the same object that matrix refers to here in the calling code. Now let's do another demo. I'm going to define another function. I'll call this clearout. Clearout is also going to accept a reference to a list. I'll call it table. And all clearout is going to do is attempt to clear out all of the elements in the table. I'm going to do the exact same thing that I did with add 1. This time I'm going to call clearout and pass in matrix. So same thing as before, make a prediction about what's going to happen. We know that matrix before on line 126 is going to print out the same output from line 124 because we haven't done anything to matrix. So 2, 3, 4, 5, 6, 7. But what about line 128? What is that going to print? So there's 2 possible outcomes here, right? Either matrix will be the empty list because via the table alias, we have cleared it out, set it to the empty list, or it's going to be unaffected. So let's run it and find out. So it looks like matrix is unaffected. Why is that? This is because Python is pass by object reference. It's kind of a hybrid between pass by reference and pass by value. So object references are passed by value, which means they are copied, but these are just variables. So if we say reassign the variable, we overwrite the reference that was stored in table. And that's why this assignment here does not affect matrix, because this is not a true pass by reference variable. This is a pass by value variable that happens to store a reference, but that reference can be overwritten. So if I go back to our diagram, what effectively happens when we call clearout on line 127 is the same thing as before. A table variable is allocated. The reference that matrix stores is passed by value, therefore copied into this table parameter variable. So for a brief moment, table is an alias for matrix, just like we saw with add 1. But then when we do table is assigned the empty list, what happens is this alias is now broken. Goodbye, broken. I'll erase it. A new list is declared, and table now stores a reference to that new list. That's why I like doing these 2 function demos, add 1 and clear out, because add 1 clearly shows the pass by reference part of pass by object reference, and then the clear out part clearly shows the pass by object part, which is the object references are passed by value, and therefore they're copied and can be reassigned. Last topic related to list aliasing and pass by object reference is shallow versus deep copies. If you take a look in a previous video, I talked briefly about making a copy. I said if you ever need a copy of a list, you can simply use the colon with no start or end indices. And this makes what's called a shallow copy, which for a one-dimensional list, which is what Candies is, will work great. But once you start getting into nested lists like 2D lists, 3D lists, etc., you're probably going to want to do what's called a deep copy. So let's do a comprehensive demo of shallow versus deep copies so that you have a sense for when you should use a shallow copy and when you should use a deep copy. And a lot of this comes back to what we've been talking about with references. So let's start by making a shallow copy. Two ways to make a shallow copy. One is we saw earlier with the slice operator. Here's another way. I'll do matrix.copy. So this is a list method, copy, and this is going to produce a shallow copy, which means that the object references are copied, not the objects themselves. Now let's make a deep copy. In order to make a deep copy, I'm going to need to import the built-in copy module. So I'm going to go up to the top of main.py, and I'm going to import copy. Back down at the bottom of our file, I'm now going to make matrix deep copy, which is going to be the return value from a call to copy.deepCopy, a function in the copy module, and I'm going to pass in matrix. You can see the documentation here says deep copy operation on arbitrary Python objects. The documentation here for copy the method says return a shallow copy of the list. So this even says shallow in the documentation. This says deep in the function name. So with a deep copy, the objects are copied, not just their references. So we're going to stick with this theme here of printing out matrix before we call add one, but we're also going to print out matrix copy and matrix deep copy. So there's matrix before, here's matrix copy, and then here's going to be matrix deep copy. Now we call add one, passing in matrix, and then we're going to print out all three of these again. And then we're going to print out all three of these again. And just so our output's nicely labeled, I'm going to put matrix after, matrix copy after, and matrix deep copy after. Same thing as before, take a moment, make a prediction about what lines 136 through 142 are going to print. Before we run this, I'm going to head over to our diagram here and draw it out. So matrix still refers to this object. It now stores 2, 3, 4, 5, 6, 7. Now I've got matrix copy, which refers to a list. And this list has two elements. The first is a reference to the list 2, 3, 4, and the second is a reference to the list 5, 6, 7. And now I have matrix deep copy, with a deep copy, the actual objects are copied, not just the references to the objects. So I truly will have an entire copy of the elements of matrix. So now let's run the code. Looks like matrix after is 3, 4, 5, 6, 7, 8, and matrix copy after is 3, 4, 5, 6, 7, 8. But matrix deep copy after is unaffected. 2, 3, 4, 5, 6, 7. 1 was not added to each one of its nested elements. So effectively what happens is, using matrix, this object over here on the left side is updated. So we have 1 plus 2 is 3. Same thing, 4, 5, 6, 7, 8. Matrix copy, when we print out matrix copy, refers to these lists, 3, 4, 5, 6, 7, 8. And then matrix deep copy has nothing to do with matrix, so it's unaffected. So we've covered a lot about list aliasing, pass by object reference, references, copies, shallow versus deep copies. I'll just wrap up this video, which covered a lot of advanced list topics compared to the introduction to list video, by saying that when you're working with nested lists or nested objects, you probably want a deep copy if you're looking to truly make a copy of, say, the original data before you start to modify it. Just keep that in mind, because it can be a tricky logic error or bug to hunt down if you think you're making a copy, but you're actually making a shallow copy and you're like, why is this data changing? Remember this, because shallow versus deep copies can be tricky if you got a logic error related to them to hunt down. Well, thanks for watching this video, which was an extension of the original List Fun video. Hopefully you learned a lot about lists and are ready to put them into practice. Thanks for watching, and subscribe to my channel for more Python videos.